All right, so I'm just going to go through these the way that I would approach them and see if that is helpful. So the molar mass of sulfur dioxide, obviously, to get the molar mass, you're going to add up. If you have SO2, it's like you have an S bonded to two oxygens. And so you want to know what is the mass of, I think of it as one molecule, but it's really a mole of the molecules. But so you're going to look in your periodic table. Sulfur is going to be 32 or 32.06. I don't know how many significant figures she wants you to use. Oxygen, 15.9 repeating, or 16, depending again on how she wants to do that. And then you just add them up. So 16 plus 16 is 32, plus 32 is 64. So 32 plus 16 plus 16 is 64. So that is the molar mass of sulfur dioxide. For number 2, where it says the molecules of sucrose in 4.1 moles, the way that I do this is I always am going to start with the number they give me. So if they give me 4.1 moles, I'm going to write that first. And then I'm going to write like multiplications with lines, going over until I get to what I want. So I start with the moles. They're asking me for the molecules. Equals molecules. And now this is my map. And this means that in order to get from moles to molecules, whatever I start with needs to go on the bottom of the fraction so that I can eliminate that unit and get eventually to molecules. So if I start with 4 moles or 4.1 moles of sucrose and I need to know the number of molecules, well, I believe that's Avogadro's number. So I believe that it tells you that at the top of the assignment where it says this is the number of molecules in a mole. So we don't have to worry really about the mass or anything here. We should just be able to go directly into multiplying by Avogadro's number. So that is the number of molecules per mole in 1 mole. So we're going to put in Avogadro's number at the top. 6.022 times 10 to the 23rd or something like that. And then you just multiply across basic. So about 4 times 6.022 times 10 to the 23rd, and that should give you your molecules of sucrose. For number 3, which is like exactly the opposite of number 2, in this case, it's asking you for moles, it's giving you molecules. So I'm going to do the same thing where I write down my molecules first. And we'll multiply in a line. I'm trying to get to moles. And so again, whatever I start with has to go on the bottom of my fraction, molecules. And I'm just going to plug in, I'm trying to get to moles, so moles is going to go on the top. Molecules will cancel out, and I'll be left with moles. So I'm just going to fill in the 1 next to the moles and Avogadro's number next to the molecules, and that'll tell me whether I multiply or divide. So in this case, once I multiply across, I would divide this by that to give me the number of moles. Molecules of water in certain number of moles of water. Again, they give me the moles, so I write that down first. 8.05 times 10 to the 3rd. I honestly would probably just write down 8050 moles. And we want to multiply it by something to give us molecules. So moles goes on the bottom, molecules on the top, and we fill it in exactly as we did up there. Avogadro's number for the molecules, 1 for the moles, and it'll give us the molecules. For the molar mass of something like strontium dioxide, I think is what this is. You could just picture it like in your head if it's SR joined up to OH twice. And then we just use the periodic table to fill in their molar masses. So we have 87.62 for strontium, 16 again, or 15.9, 16, 1, and then you would just add all of that up. 88 plus 17 times 2, and that would be your molar mass. And I think that's it. That's basically how all of these are is you just write down whatever they give you, and you either convert it moles to molecules or molecules to moles. And then that'll, by setting it up with whatever they give you first, and then putting that, whatever they give you on the bottom of your fraction, it'll help you figure out whether to multiply or divide.